All right, let's just dive right into this explainer. Today, we're exploring a radical theory that doesn't just want to tweak our understanding of the universe. It basically wants to tear the whole thing down and start entirely from scratch. We are looking at a fundamentally new way to view existence itself. It's an elegant, mind-bending journey, and it all kicks off with a massive, glaring problem that scientists have been wrestling with for decades.
So, cosmology has a massive 95% problem. Our absolute best, most successful model of reality, the Standard Model, only explains a tiny 5% slice of everything out there. The other 95%? Well, it turns out that almost everything in the universe is made of stuff we literally can't see, touch, or find. We call them dark matter and dark energy, but it's crucial to understand that these are essentially just placeholders. They're literally just names given to effects we observe, but absolutely cannot explain.
And because of these invisible placeholders, we've launched one of the most expensive treasure hunts in human history. I mean, we've buried incredibly sensitive detectors deep underground and poured billions of dollars into catching a single dark matter particle, only to find absolute silence. Year after year, decade after decade, nothing. Which naturally forces us to ask a really uncomfortable question. What if we are looking for something that just isn't there?
Section 1. Mistaking maps for reality. The flaw in our physics. To understand why we can't find these particles, we have to ask if our fundamental approach has just been wrong from the start.
We have fallen in love with the shadow, not the substance casting it. That quote perfectly captures a profound yet really subtle mistake. Physicists have become so mesmerized by their elegant mathematical models that they're basically mistaking the map for the actual physical territory. Think about it. Our current models do an incredible job describing the shape of reality and predicting how it moves, almost exactly like watching a shadow on a cave wall. But a shadow is not the object itself, right?
When scientists talk about a field, they're usually just referring to a sophisticated mathematical spreadsheet, just numbers assigned to coordinates. But true physical reality actually requires a substantive medium that holds itself together. A mathematical model is merely a highly detailed description of a state. The actual physical universe demands a medium with its own built-in properties, like stiffness or tension. A math model is just a list of data points. True reality has to be a physical, continuous fabric.
So why exactly do mathematical fields fail as physical substances? Well, there are three critical failures here. First up, the number problem. Numbers are just abstractions, not physical things. Saying a field is just numbers is like saying your height is the number 6, instead of an actual physical measure of 6 feet. Second, there's the connectivity gap. Isolated points of data in our math have zero inherent glue to connect them. It's like watching dominoes fall but having no concept of one actually physically striking the next. And third, these math models lack of modulus. They have absolutely no mechanical stretch, tension, or elasticity.
Section 2. The elastic fabric concept, a single unified reality. If the old map is a dead end, it is time for a completely new map that fundamentally reshapes our perspective.
In the standard Einstein model, space-time is the stage, and matter and energy are the actors on it, telling the stage how to bend. But this new, unified model, it erases that distinction entirely. There are no actors, there is no stage. Instead of a divided universe, this theory proposes a beautifully simple alternative. You, the planet, the stars, everything, are all just shapes moving through one single, dynamic, vibrating fabric.
And here is where the true beauty of this explainer comes into focus. This elastic fabric of reality is a physical medium that stretches, twists, and vibrates. Because of that inherent elasticity, dark matter isn't some elusive, hidden particle at all. It's actually just a massive, slow-moving geometric wave rippling through this very fabric. Suddenly, that billion-dollar mystery is solved not with an invisible particle, but with geometry. We couldn't find a dark matter particle because there never was one. We should have been looking for a wave. Think of it like Legos. An electron is like a tiny, tightly twisted, incredibly sturdy little knot in this fabric. But a muon, it's a massive, sprawling knot that uses about 200 times more fabric. And because it's so sprawling and huge, it's highly fragile and quick to fall apart. In this view, particles aren't little specks of solid stuff. They are just stable, twisted-up knots in a continuous fabric, giving us a perfectly physical reason for why heavier particles decay so much faster.
Section 3. Rethinking particles and forces. Transformation over annihilation.
This concept of unstable knots naturally forces us to completely rethink the classic physics textbook idea of particle decay. What if the classic idea of a particle vanishing in an instant is just completely wrong? The standard model treats decay like flipping a light switch. A particle just goes poof and instantly ceases to exist. But this new view suggests a much smoother journey. Instead of instantly vanishing, a piece of reality itself is smoothly and continuously morphing from one state to another. The localized properties of the fabric literally morph and blend into a new geometric state without any instantaneous jumps at all.
Just like a wave isn't separate from the ocean but is merely a temporary shape of it, these transforming particles are just localized ripples. It's actually our measurement tools that are playing tricks on us here. They create the illusion of a sudden poof because they are entirely blind to the continuous smooth transitions happening in the background. Our detectors are designed to either see a particle or not see one, forcing a binary reality onto a beautifully fluid, connected universe.
This brings us to a massive clash between general relativity and quantum mechanics, and a rather radical proposition. The graviton does not exist. We are on a wild goose chase for something that isn't there to begin with. For almost a century, physicists have tried to invent a graviton to act as a messenger particle for gravity, just to make quantum mechanics play nicely with Einstein. But nobody has ever found one, and this new model boldly claims we never, ever will.
Think about it like this. Because reality is a seamless, continuous blanket, if you pull on one corner, you don't need a tiny messenger particle to travel across and tell the other side to move, right? The whole thing moves automatically. In a continuous fabric, messenger particles are completely obsolete. Gravity is just the overall grand shape of this blanket, and the other forces, like photons and gluons, are just tiny, localized, quantized wrinkles moving through that exact same medium.
Section 4. A pre-existing unity. Changing how we view the cosmos. This mind-bending shift in perspective suggests our fundamental laws of physics are just emergent rules based on our limited viewpoint from inside the fabric.
The crucial takeaway here is that we really shouldn't be trying to glue separate cosmic pieces together. Most theories of everything try to unify isolated parts, trying to find a common ingredient for space-time, matter, and forces. But this model highlights a beautiful pre-existing unity. There are no separate parts. Space-time, energy, and matter are literally all the identical elastic fabric, just expressing itself differently. There's absolutely nothing to unify because it was never separated in the first place.
So what is the scientific path forward? To turn this elegant concept into a true scientific revolution, physicists have to follow these 3 steps. First, develop rigorous, testable mathematical equations for this fabric. Second, define the exact properties of those geometric wrinkles. And third, successfully reproduce everything we already know about the standard model. If we can map out this math and perfectly mirror what we observe, we are looking at a full-blown revolution in how we understand the cosmos.
I'm going to leave you with this final, profound puzzle to chew on. Is reality fundamentally a box of tiny, separate billiard balls? Or has it always been one single, unified, indivisible whole? If we really have mistaken the shadows of our math for the true physical fabric of the cosmos, what other incredible truths about our universe are hiding just beyond the edge of our perception? Have we been staring at an ocean this entire time, confusing the crashing waves for solid stones? It's an incredible shift in perspective, for sure.